Now let's look at some examples to actually solve the polynomial. Solve the equation x cubed 5x squared. This is a cubic equation which we need to solve. So obviously before solving, we need to actually factorize this equation. So again, we can use the loom diagram to factorize the equation. So before you start using the loom diagram, just a reminder, make sure you arrange your polynomial in the power of decreasing unknown power. So 1, 5, negative 17, negative 21. So we have to guess a root. So we guess 3 because 3 can be a factor here. A factor of negative 21 can be 7 times 3. Either one of it is negative, or either 1 times 21. So we take a smaller number, which is 3. And we perform the loom diagram method. Bring down the 1, multiply by 3, add 5 and 3 is 8, multiply by 3 is 24, add this 2, we get 7, 7 by 3 is 21, and when we add both, we actually get a 0. Therefore, it's confirmed that x minus 3 is actually a factor for this equation. Next, we have to fully factorize it before we actually solve it. So this is the polynomial equal to 0. One of the factor is actually x minus 3, and the remaining of the factor is actually x squared plus 8x plus 7, which we got it from the quotient of the loom diagram, equal to 0. So therefore now we can actually use our calculator to factorize this, our scientific calculator. And now based on this, we are supposed to solve the equation. Solve here meaning determine all the roots. So in this case, we solve each of the factor. So x is 3, x plus 1 equals to 0, x is negative 1, x plus 7 equals to 0, x is negative 7. So the solution for this particular polynomial is 3, negative 1, and negative 7. Let's actually look at the next example. In the next example, you're also required to solve a polynomial equation. So as usual, we use the loom diagram. Please be reminded before you start, arrange the polynomial in the manner of decreasing of the unknown power. So 2, negative 5.3 and negative 10 divided. Okay, we guess the root of negative 10 is actually negative 2. So what you can do here is you can actually use your scientific calculator to determine the first root, where actually you can determine the rest once you know one of the root. So you can use your scientific calculator. So bring down the 2. As usual, we perform the synthetic division. So at the end, you must get a remainder of 0. Therefore, x plus 2 is actually a factor for this polynomial. We need to get the rest of factors based on the quotient. So it's x plus 2. And also this is the quotient, so it's 2x squared minus 9x minus 5. And we use our scientific calculator to factorize this quadratic equation. So this will be a final version of factorized polynomial. We need to solve it, so we need to find root for all the polynomials. We equate each of the factor with 0. Negative 2, negative 1 over 2, equate this to 0 is 5. So these three are the solutions for this polynomial equation. So now we're going to look at the next example, which is actually solve another polynomial equation. So write the coefficient of the polynomial equation. And we guess the first root by using our scientific calculator. If you're unsure how to use the scientific calculator, please ask your friend how to use it, or you can come and see me. So bring down the 1, as usual, perform the synthetic division. Just make sure your remainder is actually a 0. Therefore, x minus 1 is actually a factor for this polynomial. The rest of the factors can be obtained from the quotient of the loom diagram. The quotient here gives you x squared plus 0x minus 3. So 0x is not written here, just to make sure that you understand what the 0 stands for. Okay, so next what you have to do is actually factorize, solve each of it, because we need to solve the polynomial equation. So x will be 1, x squared minus 3 equals to 3, so x squared is 3. So in this case, x is 1, cert 3, and also negative cert 3. So this 3 will be the solution for this polynomial. Now let's look at the next example. Show that x equals to 4 is the only real root of the equation of this polynomial. So how do we show that? The only real root? The easiest way would be if you substitute 4 into here, the end result will be actually a 0. So that is basically the root. But that just proves that x4 is the root. We want to prove that it's the only root. Therefore, we perform synthetic division as usual. We divide it by 4 because given the root is 4. Perform the synthetic division as usual. And the remainder is actually a 0. And we now try to write out this equation and try to fully factorize it. The remainder is 0, so x minus 4 is a factor. Write out the first factor. The second factor is obviously obtained from the quotient of the synthetic division. So it's basically x squared plus 0x plus 7. So it's 0x, so we don't write the 0x out. So we try to actually solve this. x4 is the factor. But when we try to solve the second factor, x squared is negative 7. So the root is basically not possible. We can't find a root of a negative number for now. So x is actually 4. So therefore, this proves that this polynomial only has one root, which is 4. So we have proved this question. Okay, now let's look at the next example. X plus 3 is a factor of this polynomial function. Find the value of p. So we can simply do this by doing the loom diagram. So since x plus 3 is a factor, when you substitute negative 3, it should equal to 0. So this is using the remainder theorem. When we substitute a factor, the remainder has to be a 0. So f negative 3, we can directly substitute negative 3 into this, and the final resultant should be a 0. So therefore, you'll get 9p minus 27 by simplifying, and the p is 3. Or there's another method where we can actually use the loom diagram. We can perform the synthetic division by using 2, 6, p, 4, and negative 15 as the coefficients and dividing it by negative 3. This is a normal loom diagram. Bring the 2 down, multiply, we get a negative 6. Add up both, you get a 0. And then 0 times negative 3 is a 0. P plus 0 is a p. P multiplied by negative 3 is negative 3p. So 4 plus with negative 3p is 4 minus 3p, or negative 3p plus 4. Multiply with negative 3 again. And you will get actually 9p minus 12. And by adding negative 15 and 9p minus 12, you will again derive to 9p minus 27. And therefore, you just equate the remainder to 0 again. So 9p minus 27 equals to 0. Therefore, p is 3. So both these methods, the remainder theorem and also the loom diagram, can be used to show or find the value of p.